জি স্যার।
আচ্ছা, ঠিক আছে। তাহলে তাহলে আমরা আস্তে ধীরে শুরু করি। আসলে মাঝখানে বিভিন্ন কারণেই হোক একটা লম্বা একটা আমাদের গ্যাপ হয়ে গেছে। তো এখন আসলে আমরা অনেকখানি গ্যাপে আছি। তো যদিও আমার কোর্স অলমোস্ট শেষের দিকে, সো এই জন্য আসলে আমার হয়তো বা আর একটা দুইটা ক্লাস যাই লাগবে। ম্যাডামের কি অবস্থা? ম্যাডামের সাথে কতদূর আগাইছে? তো তোমাদের সাথে হচ্ছে আমার লাস্ট মনে হয় এই পর্যন্ত এসে আমরা শেষ করছিলাম। সো আমার একটা ক্লাস টেস্ট নিতে হবে। ক্লাস টেস্টটা বাকি আছে। ক্লাস টেস্টটা আমি ড্রেনেজ বেসিনের উপরেই নিব, ঠিক আছে? হোপফুলি নেক্সট উইকে, ঠিক আছে? মোটামুটি অত কঠিন কিছু না। তো আমি ট্রাই করবো নেক্সট উইকে একটা নেওয়ার জন্যে। কুইজ টাইপেরই, আগের মতোই হবে আমার আগের কোর্সে যেরকম নিছিলাম। তো মোটামুটি ওই প্যাটার্নেই আমি কোর্সটা নিব, ক্লাস টেস্টটা নিব। তো আজকে ড্রেনেজ বেসিনে আমরা মোটামুটি কিছু পড়ছিলাম। আচ্ছা, 100 জন হয়েছে, তাহলে আমরা কোর্সের দিকে মনে হয় স্টার্ট করি। So, dear students, let's start from last class. So, in our last class, we discussed different methods of stream ordering. That means in a river system or in a watershed, there are having channel different width, depth, and flow, etc. That means it's main stream to sub stream and other tributaries. So we obviously we need a system or analyzing tools to determine the strength or overall features and different scenarios of a stream or of a river basin. So the most commonly used methods will be discussed in this course. This is a typical view of watershed. It's for an hilly area. You can see here that the rivers have the reeds and valleys. It consists of successive rivers and valleys. And when the precipitation occurs, the waters are collected from different areas like the small sub basin, and thereafter the water is collected by some channels and from the depending on slope, and then it is collected to another one, and thereafter here you can look that you can see the width. Okay, this is the upstream portions, and here are some small tributaries. These are the some small tributaries collecting water from these two sides of the valley. And there may have some lake, reservoirs, water bodies, wetland, watershed, etc. All of these are composed of a watershed. And when these waters are collected, and while you are moving from upstream towards the downstreams, you can see the width or the flow velocity and the flow, the discharge will obviously increase throughout the length, and thereafter once upon a time it will discharge in large water bodies like river or ocean, etc. And some portions will be percolated in the groundwater, that means in the aquifer. So this is a typical view, and this is another typical view, and showing the direction in which directions waters are moving. And so let's start the different stream ordering systems. Basically, two stream ordering systems are important, and we'll discuss the maths of these two orders. First one is the Horton stream ordering systems, which was provided in 1945, and next one is the Streller, and third one is the stream ordering. This is a very simple last one, so we often neglect this one. Let's start from the Horton stream ordering. In Horton stream ordering systems, we consider a main stream. That means among this stream system, let's consider this one as a main stream. That means the central one. In real scenario, there have some technique. How will you consider which one is the first mainstream? Suppose one may ask, sir, I can consider this portion as mainstream. Okay, why I should go for this direction? I'm also consider this one as stream ordering. In general, for the this course, this may be correct, but in real scenario, you need to decide based on the stream density and the width of the channel, with depth, flow, and the flow, also the flow direction. And in the real scenario, you may find that okay, the water is coming in this direction also from upstream, so this one must be upstream. Or if you see the with in a Google image or Google map, you may find the width of the river. So this is an conventional technique, or you may use the GPS. So in the Horton stream ordering, first we will consider one as a main stream, and thereafter we will go for our. So if it is main streams, and at this point, the left one, this is single one, and right one, this is another one. So we will next this is the main stream, and all of these are is substream. So at next step we will searching for the larger substreams. That means if this is the main stream, we have some few streams like this one, this one, this one, this one, and this one. So among all of these, we will searching for the dense one. That means in this one and this one are the dense one, because this is one single, there is no other branch in these sub branches. So it's like something like a tree. So so this is a one, and this is another one. So again we will consider, okay, this is my main stream, and this is another substreams. So all the substreams will be one. That means, so if this is one, that means first order stream. So if this is one, and in the Horton stream ordering, always one stream will propagate from a higher one. That means the first order stream will always meet the second order. That means if this the last one, if I consider this one as a one, so obviously the connecting one, this will be n plus 1. That means second. Similarly, in right side also, so if I consider this one as main, that means another sub branch, and another one is 1. So if this is 1, this one must be 2. Okay, and the single ones, in any methods, you never need to bother about the single streams, because the single streams are always 1. Okay, that means this is the end point and no other streams. So these are must be these types of single branches are always 1. So you can put 1 in without any confusion. So these are the one. Again, you if you put
Sir.
Okay,
স্যার আপনার কার্সারটা মুভ করতেছে না।
cursor, okay. Pointer option. Okay, let's check now. Is it working?
No, sir.
Let's share again. Now, let's check. Okay, I think cursor is not so important. So if you consider second order, this is the end one is the first order. So the previous one is must be.
The screen not shared.
Not shared. What's the problem? Just wait.
No, sir.
Okay. Is it working?
Yes,
Sir.
So we can start again. The laser point. So this is the basic principle of Horton method, and let's move to the next picture, the next scenario. This is the Streller method. In Streller method, actually, we put all the exterior branches as 1. That means first order. Okay. In this method, you should put 1 in all the exterior branches. That means I put 1 here, 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 and all the end point, that means end branches, I put 1. Okay. And then what will be happen? Suppose for this case, this is 1, this is 1, or these two are 1. So the previous one will be 2. Okay. That means when two first order meets at a point, the proceeding one will be higher order. That means second order. Similarly, this is first order, this is first order. Okay, so these two are first order, so this will be second order. But remind, when this is the second order and one first order meets in such way, that means inside way, that means first order and second order. So in this portion, the ordering of the stream will be must be 2. Okay, later we may discuss in details. So this is 2. Similarly, these are first order, this is first order, so this stream is second order, that means 2, and one first order may meet with second order, so this is negligible. And again, this is second order and this is second order. When two second order meets at a point, the proceeding portion will be higher order, that means 2 and 2, so the proceeding one will be third order. Okay, and this is third order. With this third order, second order is meet at this point, so this is out of calculation, so you need not to concern about this. When lower order meets with higher order, so this is the normal case. And similarly, this is first order, this meets with the third order, so this is also okay. So this is the principle of Streller methods. That means the basic difference is that in Horton method, we need to search for the main stream first, and then largest substreams, and then largest, and so on. That means we always categorized the branches with zone wise. That means first one, the main branch, and then sub branches, and among the sub branches we will search for the largest sub branches, and then we first solve for that one, and consecutively we solve all these. So, and the next one is the Shreve methods. In this method, actually, this is very simple. This is the summation. That means all the exterior branches will be marked as 1 as before the Streller methods, and thereafter only the summation. That means 1 plus 1, this is 2, 2 plus 1, this is 3. Similarly, 1 plus 1, this is 2, 2 plus 1, this is 3. And from this side, 1 plus 1, this is 2, 3 plus 2, this is 5, 5 plus 1, this is 6, 6 plus 3, this is 9. That means cumulative summation. Summation in this method. So and this method is very rarely used, and of course we only this is just for reference, and this is the most easiest one. We generally consider the Horton and the Streller methods for our analysis.
স্যার
Okay.
স্যার পদ্মা মেঘনা যমুনা নদীর নামকরণ কি এই পদ্ধতিতে করা হয়েছে?
No, this is actually the different thing. This is the stream ordering. This is not related to the name, because the stream ordering is required for the analysis of the rivershed or watershed analysis purpose. So this is not related to the name or a local name or anything or the geography.
এটা বুঝা যাচ্ছে স্যার, পদ্মা মেঘনা যখন স্যার একসাথে মিলিত হয়, তারপর তো স্যার পদ্মা নাম স্যার বিলুপ্ত হয়ে স্যার মেঘনা নাম হয়ে যায়, এর জন্য স্যার।
Oh, okay. These are actually the this actually depends on the many other things, water boundaries, etc. But in generally, this is a common concept. Okay, this is the second order, and this is sub branches. So sometimes the names may change after a certain distance for a river. So this is also maybe a reason, but in some cases you may also find without any tributaries or without any noticeable change, the name can also be changed due to the locality. That means after some certain traveling some certain distance, people are calling the different names. So this may also happen. There is no specific explanation actually. So this is another example for the river shared analysis system ordering. The first one is the Horton method, and second one is the Strehler method. The same streams are in these two methods. So if you look at the first ones, this is the Horton methods. Here actually we consider the this straight proportion as a main streams, and there are also have some clue for selecting the main streams, because in Horton methods it's required to select the main streams. In the main stream is generally having a constant flow, and it have more or less straight path. That means if you look for this one, this branch is more or less straight. Okay, again then thereafter if you go in this direction, this one is the most congested among its branches. So once we consider this as the main branch, then if we go for this portion, so this zone, and I found another one, this one more or less straight or in a flow. So I may consider this as a another branch, and from this branch this is only single one, so I can put this as one, and this is another one, and from this I find one. So this is one and two. So one may question ask, okay, I may go in such ways like this and this. So this can be my main sub main streams. Okay, or one may ask, okay, why should I go for this? I may found in this direction. Okay, these two, this direction as my main streams, but this is not feasible, because you should select in such in a rational way so that it is the main stream. Like this is the main stream. So if I consider in this direction, actually here is a sharp bend. Okay, so this may not rational way. And again main streams cards in sub streams in a some more in maximum cases in the Y shape. Okay, if you look at this, so this is a main streams and this is another one, so it merges in an Y shape. That means in a converging shape. Similarly, if you consider this point, so consider this zone, this one is the straight portion and one is propagating or merging in this point. So in a Y shape, that means in a converging shape. So this one must be substreams. And so this is the Horton's methods. But in Strehler methods, this is very simple. Put one in all the exterior points. That means this one, this. All the points is one. So if and now you can start from any point. So this is one, this is one. When two one meets, this will be two. And more than one first order meets, this will be two. Similarly, these two are the first order, so the propagating one is the two. When two first order meets at the points, the proceeding one will be three. Similarly, this is three. Now this up to this point, when will coming to the down throughout the down streams, suppose from this point to this point, you should that this is three, and one first order meets at this point. So this is your out of calculation. Similarly, you can come up to these points and then solve for this portion. That means this is first order, this is first order. So when two first order meets, this will be two. Similarly, this portion will be two. When two second order meets, this will be three. And now at this point, this is three, this is also three. So when third order meets at a point, the proceeding portion will be four. So this the remaining portion will be four. And similarly, at the last, at this section of the river, you may find another single stream is first order stream meets this point. So this is not an big deal. Now one difference in these two methods. So let's identify how many differences are observed in these two methods. Okay, so this is a question for all of you. So how many difference are you finding in these two methods? We analyze the same stream ordering, same streams by two ordering system. So let's summarize the difference. The floor is now open for you. How many types of differences are observed in your eyes, or how many dissimilarities in these two methods you may find? Just try. This is not an exam. Just try to understand.
Sir, in the left part of the Horton's diagram, we can find in the mainstream we can find four in ordered as four, but for Streller we can find two at that place.
Okay. Actually, this is the first difference. This is actually the length of main streams. Okay. In Horton method, obviously the ordering system in this ordering system, the order of this river is 4. That means at the end point, at the discharging point, we need the ordering at the discharging point actually. So discharging point, this is the 4th order. Okay. Similarly, this is also 4th order. But the question is the length of the order. That means the length of 4th order stream in Horton method. This is when we calculate or when we analyze, this will be starts from this point to this point. That means it's a long distance mainstream, 4th order. But in Horton methods, the length is only from this to this point, and thereafter this is 3, this is also 3. So the first difference is the length of mainstream. Okay, and the next one is the number of streams. In these methods, you may find second order. Look for the second order: 1, 2, 3, 4. 4 number of second order streams. But in these methods, you may find only 1, 2. Okay, 2 number of second order. Similarly, there are a third order stream, 2 third order streams, but here only 1 third order streams. And similarly also number of first order streams will be obviously 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this method 1, 2, 3, 4, 5, 6, only 6. Okay, so the number of streams, this is another issue. Okay, in these two methods there will be also difference in this is actually nothing need to be worried when we go for analyze the same streams in the different methods, so there will be difference in the calculation and the results also. So in all cases you need to mention the names in which methods you analyzed the stream system. So this is a real scenario for the and in ideal case for the simplicity of discussion, we consider some straight branches, and from thereafter another straight branches. But in reality, you may find if you go for Google Map or we show some previous drainage basin systems, so there is a congested networking, so no any specific system. So this is another stream ordering systems, another example. This is ordered in the stellar methods actually. So that I mentioned earlier, the width. Okay, so you can see the width, and you can easily understand, okay, I need to go for this way or this way, which one is the main stream and sub streams. So if you rather than a single line diagram, if you find these types of images, these will be obviously easier to analyze. So you may try at home. Many orders stream networks are available in internet. So this is another example actually. This diagram also shows the width, bands, etc. So this is easier. These types of diagrams are easier for analysis. So here is some view, some practical view. When if you see streams, so you just can guess the width and the water flow. Based on the water flow, you can guess the order. That means this is the typical fast orders and mild flow, very small flow. This one is actually valid for the hilly region. For plain land, where the water is collected from rain and other activities, natural activities. So in those cases, there may be different. So this is the typical first order, very less water flow. This is the view of second order, a moderate amount of water flow. This is third order, and finally this is the fourth order or above. Okay, the moderate amount of water flow. So these are actually for an mountainous river like Shangu, Naf, etc. in our region, in Chittagong region. So these types of rivers, and while you go for in the mountainous region, you may find all these scenarios in waterfall. So from the waterfall, waters are collected in such way, and thereafter it's marched, and the water flow is increasing, and then increasing again, and once a time it meets a river. So these are the some example. So I have already discussed these confusions when two second order meets stream meets. So in this stellar methods, this forms a third order. When a third order meets a second order, okay. Suppose in this point, this is third order coming, and from these students, this is second order coming. So what will be the stream ordering of this one? This will be 3. So sometimes the students may arise some confusion regarding these types of issues. So I discussed it earlier. Now, up to this, hopefully, if we find a stream, we can easily analyze. Also, we will try to complete a complete example, try to exercise a complete example in this class or in next tomorrow's class. Now let's start some quantitative analysis for the drainage basin. So the quantitative analysis, before starting the quantitative analysis, we actually need to complete the stream orderings, and while immediately after completing the stream orderings in any method, you may go for Horton or Stellar, any methods. So when you complete the stream ordering in any methods, you need to count down the number of streams. Okay, suppose first order streams 20, second order stream 15, third order streams 10, fourth order streams 1, like this. So you need to summarize the number of streams and in each category, that means first order, second order, third order, fourth order, or above. Thereafter you should proceed for this portion, quantitative analysis. So in quantitative analysis, we need some additional data, sometimes the watershed area, the drainage area, or the catchment area, a typical shape of the catchment area. That means in the typical shape of any catchment area is oval shape in general. This is oval shape. So we need to know the area, some equivalent length width. That means if it is oval shape, it's sometimes difficult for us to analyze. So we converted it some equivalent shape. That means for equivalent shape, we need to find the equivalent length and width, and the average length of each order. That means suppose these data are actually found from field survey. So suppose there are 20 or 10 numbers of first order streams in this stream ordering systems. So we need to summarize we need to measure the distance of all the streams and then take the average length of the first order. Similarly, if you have the 5 number of second order streams, then you need to calculate the length of all the methods, and thereafter you need to taking the numerical average of all the second order streams, so that you can find the typical length of the second order streams, and so on. Thereafter, you should start the quantitative analysis for the drainage basin systems. So the first parameter for analysis, this is the law of stream numbers, and this is actually n suffix mu. This is the number of stream segments of a given order. Okay, this will be calculated by bifurcation ratio, constant bifurcation ratio multiplied by k minus mu. That means later we will discuss how to calculate the bifurcation ratio. Okay, uh, this is actually in powered system. That means bifurcation ratio powered to k minus mu, where k is the highest order of the basin. So suppose this is the fourth order stream, or the number of highest number of stream is fourth. So k will be 4 for previous problems, and mu, suppose I want to calculate the law of stream number for second order. So mu will be second 2. That means n2 is equal to bifurcation ratio to the power 4 minus 2. Okay, and so the next one is the bifurcation ratio. How to calculate RB? RB is equal to n mu divided by n mu plus 1. Okay, so earlier we discussed we need to calculate all the number of streams. That means it have the 5 number of first order streams, 2 number of second order streams. So if I want to know the bifurcation ratio for the first order streams, okay, so in that case n mu is the number of streams of a given order. That means first order, and then divided by n mu plus 1. That means number of streams for next higher order. That means second order. That means RB. So let's take the pen. And show. Let's share. Okay, so I think it will be easy if I discuss this in the writing order. Suppose for our second order streams, I need to calculate the bifurcation ratio. So in this case, RB is equal to n mu divided by n mu plus 1. So suppose you have the first degree or first order 7, for an example, second order 3, third order 2, fourth order 1. So for bifurcation ratio for first order, this will be n mu. That means n1 divided by n2. And number of first order, this is 7. Number of second order, this is 3. So this is the for the first order. Similarly, for second order, this will be 3 by 2. For third order, this will be 2 by 1. Okay. So this is the technique. And the next one is the length ratio. Next, the third parameter, bifurcation ratio. This is the second parameter for analyzing the quantitative analysis of the drainage basin. So the third one, this is the length ratio. Length ratio, and will be denoted by R suffix L. This will be L mu divided by L mu minus 1. This is the reverse one. That means length of first order. That means length of suppose for first order, this will be not be applicable because stream ordering starts from 1. So for second order, suppose L2, this will be L2 by L1. Okay, and this is very easy. And now the question may arise from where you will get the value of L1 and L2. Suppose length of first order. So in your stream ordering systems, there are 7 number of first order streams. So you need to measure the length from the field survey. There are 7, one may be 50, another may be 100, 70, 80, or anything else. So you need to take the numerical average of all of this, and then you will get the L1. Similarly, you will get the L2, L3, and L4 average length. So this is the length ratio. And next one, area ratio. Okay, so the next one is the area ratio. That means R suffix A. This is as before, a mu divided by a suffix mu minus 1. That means area of second order divided by area of first order. So the area is also calculated from the field survey. That means suppose if it is an stream ordering system, suppose this is an second order streams, and these second order streams have some other first order streams or anything. So a certain area will be covered by these streams. Similarly, suppose this is a third order stream, so certain area will be covered by this stream. So this area is actually known as the drainage area for this main sub streams. So these data are also you'll find from the field surveys. So this is the area ratio, and the next one is the stream frequency. Stream frequency. Stream frequency is denoted by SF. This equal to summation of n divided by summation of a. That means the summation of n, this is nothing but the total number of streams of all order, and summation of a, this is actually total area of the basin. The physical significance of this analyzing terms SF, this is actually the stream frequency. That means suppose you have total number of streams including first order, second order, third order, suppose 10, 13. So you have 13 number of streams in your systems, and the total drainage area is suppose 500 kilometers square or 1000 kilometers square. So number of stream per square kilometer, this is number per area, okay, per kilometer square. So suppose on an average, each streams, a single streams covers how many areas for this drainage purpose. So this terms actually denotes such result. And the next one is the drainage density. Okay, drainage density will be denoted by d suffix d. Drainage density, this will be summation of L by summation of A. As before, the stream frequency is related with the number of streams, and drainage density is related with the length. The unit will be kilometer per kilometer square. That means on an average, how many areas or the size of the area, suppose for this is a single stream and this is an area. So to cover this area, I have on an average this length of streams to drainage the water from this area. Okay, so this is its significance. And the summation of A, this is very simple, the total basin area, and summation of L. So from which in for this point you need the take the numerical summation. That means suppose you have the first order length L1 multiplied by N1 plus L2 multiplied by N2 plus dot dot. That means you have 7 number of first orders, and on an average the length of first order is suppose 50 kilometers. So 50 multiplied by 7 plus second length of second order and number of second order plus number of third order multiplied by length of third order streams, and so on. So this is the drainage density. And next one is the
ছোট বড় সবগুলো দিতে হবে।
yes, summation means starting from first order to fourth order or higher maximum order. So all of these data, that means at the starting of the analysis, you need to summarize all this. That means number of first order, number of second order, and corresponding lengths also. Number of length, average length of first order, average length of second order, up to fourth order or higher order. Okay. And the next term is the length of overland flow. Length of overland flow, this will be noted as LO 1 by 2 dd. That means once you get the drainage density, you can easily calculate the length of overland flow L suffix O. This will be 1 divided by 2 of drainage density. Okay. And next one is the form factor. Next parameter, form factor. The form factor f is equal to A by L square. And in this case, A, this is the area of basin. That means this is as before, total area of basin. And L, this L is actually length of basin. Length of basin. In real case, this is very difficult to find a rectangular one. Okay, the basins are in generally the basins are in irregular shapes like this. Most of the cases are the oval shape. So how you can calculate the length? Okay, this length is different in this point, this point, and this points. And in practical point of view, a single river system flowing throughout a long path. So suppose for our nearby river Kornapuli, it starts from suppose in our area, it's more Rangamati Kaptai, and it's moved towards the plain land also. So how can you get the length? The very easy one is to get the average on an average width of the river basin system. That means suppose you may calculate the find the width in this point, or some other points, some average widths. And if you know the area, so the length will be the equivalent length. This will be the area by width. This is an technique. So, and next one is the compactness factor, our last parameter, compactness coefficient. Compactness coefficient C suffix C. This is the P by root over of 4 pi A. Okay. Here A is the area of basin as before. P is the perimeter. Perimeter of the basin. So how you can calculate the perimeter? This is an oval shape basin, so this is difficult to calculate the perimeters. So once you get the equivalent shape, that means equivalent length, equivalent width of the basin. So this perimeter is actually the equivalent perimeter. That means equivalent length, equivalent width. That means perimeter will be 2 multiplied by length plus width. Okay, this is the simple geometric calculation. So all of these are the parameters for quantitative analysis of the drainage basin system. And I think it will be easier for us if we go for an example. Hopefully in next class we will discuss and real problem including the numerical data. So all of you are requested to read the today's class, the stream ordering systems. You may also practice at home some typical stream orderings. The quantitative analysis is very simple, some simple mathematics. So you don't need to worry about this. The concerning thing is the ordering system. That means this is the main order, suborders, and often students make mistakes in the Horton's and Streller methods. Okay, the analyzing system of these two ordering systems are different from one another. So some students may mix both of them in some cases. Suppose up to some portion you consider the Strellers, and thereafter from this point you start Horton cell. So you may mash up these two methods. So this is not feasible. Okay, so the things you need to memorize that which methods you are using and the basic principle of these methods. So these are my suggestions, and you are requested to practice some examples. Suppose you search the stream ordering systems in internet, you may find many given examples or the stream networking. So you simply take one network and then solve. Okay, so this is only for your practice. Thereafter you can get an overall idea, and next class hopefully we will complete an example. So this will be the our end of the drainage basin systems, and based on this lecture of the drainage basin, this topic will go for an class test hopefully in next week. So please try to attend the tomorrow's class. We will discuss one numerical example. Okay, so if anyone have any question regarding today's class, so you may now ask. Okay, I think no question. So the participant is 118. Some students are missing. সিআর কি আসো?
জি আসসালামু আলাইকুম স্যার।
বুঝলাম, সবাইকে ইনফর্ম করে দিও ক্লাস টেস্টের শীট ব্যাপারেও। নেক্সট উইকে ক্লাস টেস্ট আমি নিব। আর তোমাদের অন্য ক্লাসের কি অবস্থা?
স্যার নেক্সট উইকে স্যার কখন স্যার ক্লাস টেস্ট নেবেন?
নেক্সট উইকে বৃহস্পতিবার দিলেই হবে, সমস্যা নাই হোপফুলি।
স্যার নেক্সট উইকে স্যার অলরেডি আমাদের দুইটা ক্লাস টেস্ট পড়ছে তো স্যার।
কবে?
স্যার মানডে আর স্যার থার্সডে টুইসডে।
সোম মঙ্গল। আচ্ছা তাহলে পরের উইকে দাও, সানডে। তোমাদের কোর্সের কি অবস্থা? কোর্স কি শেষ মোটামুটি?
স্যার ফ্লুইড মেকানিক্স স্যার একটু বাকি আছে, আর স্যার ফ্লুইড মেকানিক্স এর ভালোই বাকি আছে, আর স্যার মেকানিক্স CE-201 এটা স্যার অনেক বাকি আছে স্যার।
তোমরা সানডে বা মানডে দেখে একটা ফ্রি টাইম দেখে
এই উইকের নেক্সট উইকে স্যার পরের উইকে স্যার মানডে আমরা দিতে পারবো স্যার।
হ্যাঁ মোটামুটি একটা দেখে আমাকে শিডিউলটা জানাইও।
ওকে স্যার।
মোটামুটি 10টা 11টা এরকম করে একটা ফ্রি টাইম দেখে হচ্ছে আমাকে জানাইও, তাহলে হচ্ছে আমি শিডিউলটা দিব আর কি। ঠিক আছে?
জি স্যার।
ওকে, তাহলে এই পর্যন্তই থাকুক আজকের ক্লাস।
ম্যাটেরিয়াল একটু দিয়ে দিলে ভালো।
হ্যাঁ আমি ম্যাটেরিয়ালসটা এটা দিয়ে দিব, প্লাস হচ্ছে তোমার রেকর্ডটাও দিয়ে দিচ্ছি। ঠিক আছে তাহলে। ওকে।